Hey guys, welcome to my YouTube channel, and today I'm recording 5070 paper 2 October November 2020. This is Cambridge O-level paper. I've already solved many questions from this paper, around 4 questions I've already solved. You can check them out in the description down below. I have put the links where there are the solutions of these questions. You can also check out my playlist that I've put for several years where I've covered winter and summers of 2016, 17 and 18 as well. And without any further ado, let's start question number 5. Question number 5 says, alkenes are made in an oil refinery by cracking hydrocarbons. Part A says, give one other reason why petroleum companies carry out cracking. Okay, so cracking is important because through this process we are able to attain petrol, and petrol is a very important fuel. So that is why its answer is going to be that the reason for cracking, like petroleum companies carry out cracking process for manufacturing petrol. Alright, moving on to part 2. It says complete the equation for the cracking of tridecane C13H28 to form propene C3H6 and one other hydrocarbon. Alright, so its answer is going to be, since we have 13 over here and we have 3 over here, that means we need to have 10 C's, 10 carbon. Alright, and we need to have around 6 minus 28 is going to be 22. So 22 hydrogens. In this way it is completely balanced, and we have been able to achieve a compound that carries out during cracking. During cracking, as you know, the cracking process is a process in which longer carbon chains are broken into smaller carbon chains. Alright, they follow some principle. However, there is no other product that is being produced. For instance, in different kind of reaction, we see at times hydrogen being produced, or water, or any kind of product. However, over here we just have hydrocarbons as a reactant as well as the product, because this is a cracking process in which we are just breaking down the chains. Moving on to part B, propene is an alkene. Write the general formula for an alkene. Alkene general formula is CN and hydrogen 2N, which clearly means that if, for instance, we have 2 carbon, we need to make something with 2 carbons, so it's going to have 4 hydrogens with it. This is the general formula makes it really easy to determine how many hydrogens or carbons will go within the proportion. Moving on to part 2, propene reacts with steam by an addition reaction. Predict the molecular formula of the product of this reaction. So propene, and we're talking about steam reaction here. Propene, that means 3 carbons. Since we have propene, alright, that means 3 carbons, and ene means alkene. So predict the molecular formula for this product of the reaction. So for it we will have C3, because it's a steam reaction. A reaction with steam, that is addition reaction. So we have H8, and we also have 1 oxygen. Alright, this is pretty simple. If you know all the reactions and what are its products, it will be really easy to solve it. If I go into the detail right now, it's going to take a lot of time. So we are here mainly focusing on the paper solution. Moving on to part 3, when propene undergoes incomplete combustion, a small amount of carbon dioxide is formed. Name 2 other substances formed when propene undergoes incomplete combustion. Incomplete combustion calls for 2 major products, that is carbon monoxide and water. Whenever we are talking about incomplete combustion, we'll always have carbon monoxide, and whenever we are talking about complete combustion, that means carbon dioxide and water is being formed. So over here the answer is carbon monoxide and water. Moving on to part 3, the structure of propene is shown. Reduce the partial structure of polypropene to show the 3 repeat units. So for this, we are first of all going to consider, we are making it as polypropene. That means we are having a lot of carbons. However, it's like a poly chain. Alright, so over here we consider the central C. This is how we are going to form it. So we're going to have C, and then the C is connected to CH3. So we'll have CH3 over here. Alright, and then moving on, this C is also connected to one hydrogen, so we'll attach a hydrogen over here of course. And then because we are making a poly structure, so this double bond will not be we're not going to draw it over here, we're not going to consider it, it's going to have single bonds only. And the C is connected with 2H, that means 1H here and the other one here. Alright, so this is how you're going to draw one unit. Alright, now I'm going to continue the unit, and this is how it will be done. So this is how it is going to be done. Alright, and we have drawn 3 structures over here. If we can highlight this, 1 repeat unit, the second one, and the third one. Alright, so this is how it is supposed to be done. Moving on to section B, question number 6. Methanoic acid and ethanoic acid are weak acids. What does the term weak mean when applied to acids? Weak acids always, whenever you're talking about weak acid, that means they do not completely dissociate. That is why they are known as weak acids. So moving on to part B, methanoic acid, HCO2H reacts with magnesium powder. Construct the equation for this reaction. So the equation for this reaction will be something like, we have methanoic acid's formula over here. So this is how it will be done. Now to balance it, we are going to put a 2 over here. Alright, so basically what has happened is that magnesium has reacted with methanoic acid, and because now magnesium is coming into its ion form, they form ionic compound. Mg has the valence, the charge basically of 2 plus. So we are going to have 2 methanoic acids part. We are not having methanoic acid over here. Alright, so this is, and this is how it will be done, and we have hydrogen over here. This is how it will be formed. Pretty simple equation. Moving on to part 2, state and explain how the rate of this reaction changes when the experiment is repeated using a piece of magnesium ribbon with the same mass as the powder. All other conditions stay the same. Include in your answer ideas about collision between particles. So here, first of all, rate decreases. And why does it decrease? Because there are fewer magnesium particles that are exposed, hence lesser collision takes place. Collision's frequency decreases. So this is how you are going to write its answer, and it's just of 2 marks. Moving on to part C, methanoic acid reacts with propanol C3H7OH to form an ester. Name and draw the structure of this ester showing all the atoms and all of the bonds. Name and structure, that is what we are supposed to write over here. So basically the name for it is going to be propyl methanoate, since we have methanoic acid and we have a propanol. So propyl methanoate structure is going to be somewhat like this. The ester, and the name of the ester, as I just told, propyl methanoate. This part comes from the acid, carboxylic acid, and this part comes from the alcohol. Alright, an alcohol and acid always together they form an ester. Alright, moving on to part D. Ethanoic acid is present in vinegar. Name the organic compound which is converted to ethanoic acid when vinegar is made. So the organic compound is basically ethanol. Alright, and ethanol is an alcohol, and then it's later on converted to ethanoic acid. Then moving on to part 2, what type of chemical reaction is this? This is known as oxidation, because through oxidation we can convert alcohols to carboxylic acid. Alright, moving on to part E, the table shows some properties of 4-carboxylic acid. Predict the density of ethanoic acid. So this is the table in which we have methanoic acid, ethanoic acid, propanoic acid, and butanoic acid. Basically, as you go down, the number of carbon atoms are increasing, and as we can see, the formula is here with us. Density as well, it is also decreasing. The number of carbons are increasing and the density is decreasing. So if we need to predict ethanoic acid's density, it's going to be somewhat lesser than 1.22 and going to be greater than 0.99. So you can write any number over here, it's up to you. I'm writing 1.20, you can write something else. You can either write 1.21 or 1.19, depends on you. Moving on to part 2, describe and explain the change in the boiling point as the number of carbon atoms in a molecule increases. As the number of atoms increases, as we can see over here, the boiling point increases because we need greater temperature to overcome the forces of attraction between the molecules. Alright, so that is why basically to overcome the intermolecular forces we need greater temperature, since more carbon atoms are increasing. So this is all that you have to do in this question. You'll easily get 10 marks. That is it for this video. I hope you found it fruitful. In case you have any query, make sure to drop it in the comment section down below. I have already solved its part A, part 1 and part 2, and you can check them in the comment section. I put the links of the playlist. Go ahead, check it out, and if you have any request, make sure to again mention it and I'll try to fulfill it. Thank you so much for watching, and best of luck for your exams.